So my name is Alex Shaw. I work at Laude Institute, and I am a creator of Terminal Bench and Harbor. And today I'll mostly be talking about Harbor. I just want to present a few slides describing what Harbor is, and then show you guys a demo of how you can use it. So Harbor is a simple framework for specifying and running agent environments. And to tee up the need for Harbor, I'm going to ask you to imagine that you're an agent developer. And that might not be such a far-fetched thing to ask, because there probably are many agent developers in this room right now. So if you're a good agent developer, the first thing that you'll think to yourself is, how do I know if my agent is actually good? Right? As you're exploring different tools that you could give your agent, different MCPs, different ways of managing context, you're going to want a way to measure whether or not these things are improving or harming your agent's ability to complete tasks. So again, as a good agent developer, the next thing you'll think to yourself is, I should make an eval. And then you ask yourself, well, what do I need for an eval? And obviously for an eval, you need data. So you need some way of giving your agent tasks that it should do, and then some way of measuring whether or not it did those tasks. So what's the first component of data for measuring agents? Well, you need some way to tell the agent what it's supposed to do. So this is the instruction. And ideally, this instruction should match roughly what the agent would be seeing in a production setting, right? Like whatever it's initially being prompted with, this is the type of instruction that should go into your data. Next, you need some place for your agent to take action. And since this is to measure agent performance, we'd probably prefer to do that in a sandbox than actually pushing this into production first to measure the agent performance. So we have this simulated computer using a sandbox with something like Daytona. And then finally, you need a way to measure whether your agent completed the task in the sandbox that it was given, that it was instructed to complete. And that just means you need some verifier. So in Harbor, the way that you specify these tasks is using a file directory, and it has the following files in it. So an instruction, some configuration information, and then environment specification files, an optional solution, and then a test script, which is just in charge of producing some reward at the end. So here's an example from Terminal Bench. So we built Terminal Bench and shipped it using Harbor. So this instruction says, create a Python function called run tasks, where each task is an async job to be run, and max concurrent is the max number of tasks that can be run concurrently. Just use the system Python to implement. And then most importantly at the end, sometimes I cancel runs via keyboard interrupt, but I want the task's cleanup code to still run. And the catch here is, if you use the legacy Python way of doing this, it doesn't actually execute cleanup when the number of tasks is greater than the max allowed. So kind of like a niche problem. This is one that I created. And as you might imagine, the reason I created this task is because I ran into an extremely painful bug that I tried to solve with all of the coding agents, and none of them were able to solve it. So I ended up having to go dig into the async IO docs and figure out what the solution was myself. And then I put this task into Terminal Bench, so now every model maker in the world is incentivized to make their model good at this type of thing. So this is an example of how specifying a task can actually directly lead to performance improvements. And I think by now most of the models actually do solve this task. So here's like examples of other tasks people use. These are all coding related. We've seen people start to create professional services tasks, finance tasks, legal tasks, all sorts of tasks fit into this framework, not just coding. Okay, great. So you have this data now. We have ways of specifying tasks. We also need to use this data to actually measure an agent's performance. And the question is, how do we do this? So we have our tasks right here. And this is kind of the general flow of how Harbor works. So the Harbor framework under the hood is really just doing this. So it's starting a sandbox, and then it's passing this sandbox to an agent and letting the agent interact with it. So most of the time, this actually means dropping the agent into the sandbox and then letting it run autonomously, like Claude Code or something. But sometimes people prefer to run their agents outside the sandbox as well, and that's fine. This agent then produces some trajectory, and when it's finished, we pass that sandbox to the verifier, and the verifier is in charge of producing a reward, which eventually gets aggregated into either eval results or like this could be used for reinforcement learning or any number of things really. Okay, so you do this and you have maybe 100 or 1,000 tasks that you want to run on, and the first thing you think to yourself is, wow, these are really slow. It's going to take a long time to run 1,000 of these in sequence. And this is where Daytona comes into play. So we hit this problem pretty early, and we were looking for solutions to offload some of the compute burden from our local computers, and we integrated with Daytona. And that's kind of been the secret, is you take your eval, your agent, and your cloud sandboxing, and all of a sudden you can cook up 1,000 or thousands of rollouts in parallel. And I'll show a demo soon that kind of shows how this works. So now, more broadly, just to wrap this, Harbor is 3 things. So 1, it's a format for specifying agentic environments. 2, it's an open source framework for performing rollouts in parallel with any agent. And 3, it's a registry of popular training and eval environment sets. So here's an example of like how you actually run Harbor inside the terminal. It's also a Python SDK, so you can do that as well. And then here's like our self-effacing tweet that I had to put in here because it's something Swix tweeted a couple weeks ago where he said, amongst other things, he said, my team at Cognition has made it a top priority to migrate all evals to Harbor as well. Yeah, we're seeing a lot of people pick this up. We're getting really excited about it, and we have exciting things on the roadmap. So I think without further ado, I will switch to a demo and show you all what it actually looks like to use Harbor. So this is when it starts to take talent to hold a mic and type at the same time, but I think we'll figure it out. So first I'll just show you what it looks like to initialize a task. So I come in here, I'm just in my terminal, everyone's favorite tool now, and I can run UV run because I'm in a UV environment, and then Harbor tasks init, and I will call this one, we can call this demo, so that's the name of the task. I click enter, you can see it has initialized this task, and if I clicked into one of these files, it would allow me to like start editing and adding logic into these tasks. For the sake of this demo, I've already created 2 tasks for us to look at, so let's jump over to those. So I have 2 tasks. I have one called Daytona Inception, and I have another task called MLflow Register. So if we click into Daytona Inception first, it says, so remember, this is the instruction being given to the agent inside the sandbox. And it says, use the pre-installed Harbor CLI to perform a rollout on the Hello World dataset using the Oracle agent in the Daytona environment. Set the output directory to, et cetera, et cetera. And so what's actually happening here is we're spinning up a Daytona sandbox, we're putting an agent into it, and we're saying, inside this environment, now you spin up a Daytona sandbox and you put an agent into it and do a rollout. So that's why it's called Daytona Inception. So that's one task, and then we have this other task called MLflow Register, which says start a local MLflow tracking server in the background on localhost 8080. Randomly initialize a linear regression model using sklearn and register it as GPT-7. Train it on a random data set that has 3 features. So this is going to measure the ability of different agents to train GPT-7, and we'll see shortly which ones are capable of that. So now that we've looked at some of those files, I'll just show what it looks like to spin up the server itself. So again, UV run, and then Harbor run, and we'll do on this one. So initially, I'm just going to spin up the Oracle agent, so it's just going to execute the gold solution so we can make sure everything is working correctly. And for this one, I'll start with the Daytona Inception task, and then I'll say run it in the Daytona environment. And then one catch here is I have to pass an agent environment variable to specify the Daytona API key, because by default, right, this agent won't have an API key inside of its sandbox, so we have to pass that through. Oh, shoot. It takes talent to type with one hand at a live demo. If it wasn't risky enough already to do a live demo, now it's especially risky. Daytona API key. Okay, enter. So hopefully that works. And then over here, I'll start the other one. So great, we can see like this task is spinning up and running now. And then the other one, I'll do UV run, harbor, run, dash PML flow this time. And then I don't need to pass any environment variables because we're not using Daytona inside of there. But I will still use the Daytona environment. Great. Okay. So these should both kick off, awesome. And then you guys are gonna have to watch me slowly type 2 more commands and then we'll almost be done. So UV run, now I'm actually gonna run 5 agents on each of these tasks. So we're gonna run 5 agents to see if these agents can actually complete these tasks. So UV run, harbor, run, and then I pre-created a config to run these. So I actually don't have to type in all the names of the agents, but you'll see when we look at the viewer after this what the agents, which agents we chose to use. Oh, Daytona API key. There we go. Oh. Okay. I think that will work. And then one more, UV run, harbor, run, dash C, and then we'll do the other config, which is ML flow, and that will just work. Okay, great. So you can see I've queued up 5 agents on either side, and they're all running in parallel now. So now we have 12 sandboxes running. Well, technically more than that because 2 sandboxes get used for the Daytona inception one because of the inception. So we have like, I guess 19 sandboxes running. But even that is actually like on the lower end for the number of sandboxes we're usually spinning up with Daytona. So it's been extremely helpful for us. And then I'll come in here, and what I can do now is I can say UV run harbor view jobs. So now I'm starting a local server where I can actually go and look at, oh, well, there we go. All right, come on. There we go. Okay. So this is my local server running, and you can see the different jobs that I've queued up. So you can see the agents I queued up were Claude Code, Codex, Gemini CLI, Goose, and Terminus 2. And then here's some of the other, actually, I need to refresh this. Okay, so let's click into this one. This is the MLflow Oracle agent. There's no trajectory because the agent is not actually an agent, it's just executing the gold solution. But if I look at the logs, I can see, okay, the gold solution executed correctly, and yep, we now have GPT-7, and I go to the verifier logs, and I can see, okay, all of the unit tests passed. And sure enough, we have a reward of 1 up here, so the task passed successfully. Okay, so our tasks are working, and then I'm actually gonna cheat and go to this other jobs view where I had pre-run these 5 agents on each of the tasks. That way we don't have to wait for the runtime to actually complete. So if we click into, let's go to, I think, MLflow register first. So we can see that, right, we have these 5 agents again. We can see each of their tasks that they ran on. And then it looks like 2 of the agents failed and 3 of them succeeded. So ironically, Codex failed to train GPT-7, but Claude succeeded to train GPT-7. So if we click into one of these, we can see, okay, here's the trajectory. We can hover and see like where most of the time was spent. So it looks like step 10 took 13 seconds. So let's see what's going on there. I guess it was just Claude mostly thinking, where it says, great, GPT-7 has been trained and registered correctly. And we can see like some of the things it thought to itself. So the user wants me to start a local MLflow tracking server, register as GPT-7. It didn't seem to see the irony in that. Let me start the MLflow tracking server. We can see some of the commands that it ran. So here it just checked like what the version of MLflow was, et cetera. And yeah, this gives us some visibility into what actually was going on. If I click into the codex one that failed, I can try to look through this trajectory, and it might be interesting. I can see up above that the agent timed out. So ultimately, it ran out of time before it could train GPT-7. And if I come to this summary here, I had Haiku generate a summary for me of what actually went wrong here. And you can see it says, Codex verified the Python implementation, started the server, verified the server health, and then for some reason killed the MLflow process, and then did not proceed to model creation and registration because it ended up timing out at this point. So Codex, for whatever reason, decided it wanted to go and start running some other commands, and ultimately that led to its downfall. So yeah, the very last thing I'll show you guys, because I think I need to wrap up soon, is what it looks like to run terminal bench to really queue up a ton of tasks. So harbor run, and then we'll do -d terminal bench, and then -e Daytona, and then we'll do -n100, which means run up to 100 in parallel. And you'll see, yep, so we just queued up 100 rollouts in parallel that we're all running right now. And these things are used for model training, for reinforcement learning, for like evolutionary optimization, evaluation, really anything. And with that's my demo. So please feel free to check out Harbor. Feel free to use it to build your agent evaluations. And we're constantly trying to make the framework better. Thank you so much for listening.